Hello and welcome to this presentation on software process and lifecycle. I am Akshay Saji, first MCA student of Kannur University campus, Mangatuaramba. Software engineering is a structured and disciplined approach to developing software. It applies engineering principles to ensure quality, reliability, and efficiency. In this session, we will explore what a software process is, understand various software process models, and break down the software development lifecycle or SDLC, which helps team manage complex software projects effectively. First of all, a software process is essentially a roadmap that guides software development from start to finish. It includes key steps like specification, design, development, testing, and maintenance. These structured activities help manage complexity, reduce errors, and ensure quality. Think of it as a blueprint that defines who does what and when, making the software more predictable, organized, and successful. The core activities of any software process include specification, where we define what the software should do, design, and implementation, where we build the software, validation, where we test it to make sure it meets requirements, and evaluation, where we update or fix it after release. These four activities can create a loop or continuous improvement, ensuring the software remains useful and effective over time. Different projects need different approaches, which is why we use software process models. There are frameworks that organize the development process in various ways. Common models include the waterfall model, incremental model, spiral, V model, and agile models. Each of them has strength and is best suited to specific project type. For example, waterfall is good for well-defined projects, while agile suits projects that require flexibility and fast changes. So first of all, coming into the waterfall model, the waterfall model is a linear step-by-step approach. It starts with requirements, then design, followed by implementation, testing, deployment, and finally maintenance. It's easy to understand and manage, but not flexible, making it hard to adapt to changes once development starts. That's why it works best when the requirements are clear and unlikely to change. Okay, next one is incremental model. In the incremental model, the software is developed in small sections or increments. Each increment adds more functionality and is tested individually. This allows quicker delivery of a working product and easier testing. However, it demands strong planning and can become complex when integrating multiple increments. It's ideal for projects where feedback is needed early and often. Okay, coming to the next one, spiral model. Spiral model blends elements of both waterfall and iterative models. Each loop or spiral represents a phase: planning, risk analysis, engineering, and evaluation. It's great for large, high risk projects because it emphasizes risk management. It also allows repeated refinements. However, it's more complex and expensive than other models. So it's used when project requirements are expected to change a lot. Coming to the next one, V model, validation and verification. The V model is like the waterfall model but adds a strong focus on testing. Each development phase has a corresponding test phase. Okay, ensuring validation and verification throughout the process. It's highly structured and great for systems that require high reliability, such as medical or aviation software. However, it doesn't handle changes well, so it's best used when requirements are very stable. Coming to the last one, agile model. Agile is a flexible, iterative approach focused on teamwork, customer collaboration, and rapid delivery. Work is broken into short sprints and feedback is continuous. Okay, then framework will like Scrum and Kanban are commonly used. Agile allows frequent changes and rapid response to user needs, but it requires skilled teams and close communication to work effectively. Next, we are going to see the topic related to software development lifecycle or SDLC. SDLC is a structured process that outlines the key phases in developing software: requirement analysis, design, implementation, testing, deployment, and maintenance. Each phase has clear goals and deliverables, making it easier to manage projects and delivery quality software on time. And deliver quality software on time. SDLC helps teams stay organized, reduce risk, and ensure each step is completed thoroughly. Let's break down the SDLC phases. First, we gather and analyze requirements. Then, we design the system architecture. Next, we implement the system using code, followed by rigorous testing to find and fix bugs. Once it's stable, we deploy the software for users. Finally, we maintain and update it as needed. This clear structure helps ensure quality and efficiency. Okay, STLC is a crucial because it provides a roadmap for building software systematically. It improves planning, tracking, and quality control. By following defined steps, teams can reduce errors, manage risk, and deliver reliable software. It also helps with the resource management and communication among stakeholders, ensuring the whole process runs smoothly from start to finish. Choosing the right model depends on factors like project size, complexity, risk level, and client needs. For example, Agile suits fast moving, uncertain projects, while Waterfall fits projects with clear requirements. There is no one size fit all model, so understanding the project's needs and constraints is the key to selecting the best approach and ensuring project success. Okay, in summary, software processes and models help manage the complexity of software development. Each model, whether waterfall, incremental, spiral, V model, or agile, has its unique advantages. The STLC provides a structured path from idea to deployment and maintenance. Choosing the right approach ensures better project outcomes, higher quality, and satisfied users. Thank you for watching.